Yeah. Good afternoon, everyone.
Good
Good
afternoon.
afternoon, sir.
So I think this is the next session. I'll show you the settlement value. I'll show you the settlement value. See, GBP and all, we have to check in SAP to safe only. Okay, here we can see only settlement value, share value, moments value, and all. Those things we can see here. Okay, first of all, I'll show the settlement value. I think we have applied every forces and all. Okay. I'll just revise what we did in last class. First of all, we have the dimension of water tank 6 meter across 6 meter, and the depth of the water tank also 6 meter. Okay. Then we have modeled it in ETABS, sorry, in SAP 2000. And we got the we modeled it and we got the shape, water tank shape, and with the top slab also. We have designed the top slab also, and I have given the opening here. You can see the extrude view. We have given the opening for the water tank here. Okay, and we applied all the loads. We have applied all the loads. Okay, let's say soil load. We'll just do the undeformed shape. We have applied the soil load on the wall and water load from inside to outside. Okay, and then we have applied the water gravity load at the base. You can see towards gravity minus 60 kilonewton per meter square, and we have applied the soil load, okay, soil gravity load outside this area. We have applied minus 40. Okay, then we have applied the live load also at the top slab of 5 kilonewton. So minus sign indicates towards gravity. Okay, and see the dead load. We have applied the dead load also at the top slab minus 2 kilonewton per meter square. Okay, so these are the all load which we have applied. Okay, so now I will just run the, I think I have run the analysis, and I'll show you the settlement value. So for the settlement value, make sure that you are taking the dead load plus live load, or at least service combination. I'll just take for the dead load plus live load combination. So instead of dead load, live load combination, I have, these are, let's say, whatever the loads we have considered in the service combination. Can you see dead load plus live plus soil ground? Okay, and the including water also. Okay, so these are the water and soil are nothing but the live load only. Let's say if you are considering soil load, so in the if there'll be water in the soil, so it may move or it may settle. So I am considering that soil and water also live load. Okay, so it's nothing but the dead load and live load combination only. So dead is a self weight, and live load are soil, including soil and water load, water gravity. All the loads are live load. Okay, these loads can change. That's why I'm considering as a live load only. So in the foundation, generally we are taking dead load plus live load, but in this live load, water and the soil is included. Okay, I have included in that load combination. Okay, I have included all the load in this load combination. Okay, So for the now we'll check the settlement value. I'll just open the plan for the service envelope. You can say resultant or user value. Okay. So here the units are in meter. Okay. All the units are in meter. So you can see U3 value is 0.03 means 30 mm. Okay. Settlement is 30 mm. So how much settlement we have considered to find? So safe bearing capacity by settlements, I think we have considered 50 mm. Okay. So you can see here.
No, sir, 25 mm.
So later we I think change.
Yes, sir.
So SBC 300. Okay. No. Yeah, what minute? I think we have given the 30 mm only. Sorry, 50 mm. So we have taken 200 divided by 50. So it is in meter 0.00 0.5. So compression, I'll just replace it once again. Okay.
Why are we taking only 5 mm deflection?
What 50 mm?
Sorry, 50 mm. Sorry.
Actually,
we
will take according to the soil report. Now we are assuming that it is 50 mm.
okay.
Yeah. So let's say I'll just consider to how much 25 mm. Let's say 200 divided by 0.025. We'll see we'll see if it is passing or not. Just replace it. Okay. Just replace. Okay. And again we have to select these 4 points and we have to check the 10%. Spring constant. So global, it should be 10%. So 200 divided by 0.025.
Yeah, I just had you had no.
How much it will be? 8,000 multiplied by
Yeah.
0.1. So 10%. 80. So it become 800. Replaced. Now run the analysis. Now I have given the settlement 25 mm. Okay. I'll check the settlement value, how much it is coming.
Yeah. Yes.
So it is coming 14.5. You can see here 14 mm is the maximum settlement. Okay.
Yeah.
According to my spring constant, it is 14 mm. Okay. Here also 14 mm. 14 mm.
Yeah, floor to floor height you were saying.
15 mm. 15.8. So it is less than 25 mm. Okay. 0. 0. Understood. It is 14.5. So this is the settlement value. U3 value. I think here is the maximum. I think here is the maximum at the
Right. That's right.
Yeah, here 15.8 is the maximum. Or you can see here the maximum value 0.018 means 18 mm. It's the maximum value. It is less than how much?
Like because in 900 if we go, we have
25.
Yes, like less than 25. Okay.
When we make
This is the resultant
the
also.
other dimension is increasing, no? That is fine. If that
14
is
mm.
fine, then there is no issue.
It's at 0.0818 only. 18 mm. So we can see the settlement here. Okay. GBP and GBP we can see in the safe only. Okay, not here. We can apply the spring constant only. We can see the moment and shear value. So now we'll see the.
So we have to export for checking the
Yes,
GBP.
only base, only this base you can export. To go to file, export, You have the F2K file, I think. Yeah, F2K file. Can you see save F2K file, text file?
Yes,
You
sir.
can, you can export this base to save. Okay, you can design the footing. So better before we go for the before we go for checking. So we can mesh it also, but it's 1 meter by 1 meter. Already we have meshed it. Okay, if you want more meshing, you can increase the meshing size also.
Okay. And in the inner ring also, then inner ring also we are going with columns, right?
Okay.
I'm not sure.
Yes.
Sir, if you are saying that if we have to export this file to save, so there is also need to we have to design this slab na. Below this there will be no footing na. This will
No, this is the base only.
this will act as a footing na only.
Yes, this is the footing only. Correct.
But for this one,
Understood.
if
Yes,
required,
sir.
do you want me to work on the column? Because that's
So-
possible. If you want me to work on column, then here
So we have
can
checked the
take one
settlement.
column.
I'll check the
Rather
value.
than working on
Is there any
the
deflection at the top slab?
Because the previous design, yeah.
18.4.
Why? Because ma'am, this was
So it is less
600
than.
and this is 70.
So it is also
Except for the
deflecting
whatever
18.4.
other angular
How
shape
much?
was and the one goes
18.4.
across grid
Now we'll see the
Ah,
deflection value.
Right. Along grid A, it is
So which value?
750. And
Span
along
by
grid B and the angular one, whichever is there. was
350
600.
or
And the dia of bar that if you see. ma'am,
20
it is
mm.
32
Okay.
bar at 150
So what is the
centimeter
span?
center.
6 meter.
The detailing that we got before, which is
So
huge.
6,000
And for
divided by
600 wall also,
350.
we
How much?
got
Just
32 and
calculate.
25 alternator. This 32 at 300, 25 at 300. Yeah.
17.14.
300 center to center.
17.14.
25 mm bar means
Yeah,
32 bar, 25 bar, 32 bar, 25 bar,
17.14.
effective
Okay.
is 150.
So and here how much?
Yeah, that is on.
16.
Right. And
So
along grid A, we were getting
here is
32 at
18.4.
That
18.4
Yeah, then we
minus
had to give that because the dome base was demanding more because of the
16.
weight. So there we cannot go for higher T-bar, right? We had to take it all the way from down. We didn't have a choice.
16. It is
So
how much?
we had to do that.
2.4.
So just to save some cost, if we are going for cast sensitive, we can try with columns. If you want me to do that, I'll do that also. I'll work on that option.
So how much it will
Yeah,
be?
here,
So 2.4 if you multiply with the creep coefficient. So if you want to multiply, you can multiply. Okay. So 2.4 into just 2.2 just multiply creep coefficient 5.28. So it is passing in the deflection also.
and
Okay.
our
It is
ground
passing in the
level
deflection.
is 1.5 meter down.
It is less than.
as per
It is
all
very less
our
value.
previous drawings.
Even if you multiply
Now
with
it's going to be 0.5
2.2
meter down.
or 2.5 or 3 values, so it will be less than this value. Okay, no?
1.5 meter down.
So it is passing.
The
Like,
16,
Now it's going to be 4 meter above and 0.5 down.
sorry.
the 16 is we take the value under the file. Or
No, here we are taking.
Can you explain again, sir, please, little bit?
1 minute. So we are checking the value here 18 point. See which one is the support for the top slab. So we have the wall like this. We have the wall. We have the wall for the water tank, and we have the wall like this. Okay. It is continue, and this is the wall. So for this slab,
No, this is 1.15 meter down.
For
From
this
the
slab,
ground level, we are elevating it 1
which
meter
one is the
above,
support?
is it?
This wall, na? This wall. So you check the deflection value here. How much it is? 18.4, correct, na? And check the nearby support. Which one is the nearby support?
I was understanding it.
This is the nearby support, na? How much? 15.9. This is the nearest support.
0.5 meter.
Here is 16,
0.5 meter
15.8.
down.
So this is the
And
nearest
1
support.
meter
So
above.
15.8.
But this is going from the zero, it is going 1 meter above, I guess, na?
15.8. Just calculate. So you have to check the deflection
Ah,
with respect to the support.
yeah.
That is called axial
This is
shortening.
what I was also thinking, ma'am. I was thinking that with the current, if we
Understood.
elevated, then best. Nothing like.
Understood. Where you have to check.
yes, sir.
So if you are
Yes,
checking the
sir.
deflection here, you check the deflection with the support also. Correct, no? you do the minus sign, minus, subtract this value from here to here. You get the exact deflection. Then if you want to multiply with the creep coefficient, you multiply the creep coefficient. Okay. Then you get the exact deflection and check with the value of, it's also simply supported now. So it's also, yeah, this side is fixed support, this side is fixed support, and this is the slab. It is deflecting like this. Okay. So it is deflecting here. So you have to do the axial shortening from here to here. How much is the maximum deflection?
Sir, in SAP, creep analysis is there.
I think auto sequence. 1 minute. Let me check. No, auto sequence is not there. Even creep analysis is not there.
You're not segmental. Because sir is still in the idea that it is
Okay.
R.
So in water tank, if you are thinking that I'll go for the creep analysis, don't think. Okay.
No, I told him, I clarified him that it is not R. Because
So understood.
you remember, no, I asked you asked me once and I told you
Yes,
that
sir.
it is R, and then you told me.
So
no,
now
segmental
next
now.
step is we have checked the deflection
I told
value,
him the same
okay,
thing.
and the settlement
And
value.
then he told
So
me that
next
I will
is
suggest
I'll show you the bending moment value.
we need
Okay,
to have a discussion
go
on
to
that
display
also. I
and
think when we were sitting at
from
the
here
table,
and
we
shell.
also-
Show forces and stresses and shell.
Mhm.
So for the bending moment diagram, what you will go for? You will go for the envelope of strength envelope. Okay, and it should be resultant force. So first you check the M11 direction. Okay, step like. So M11 means 11 means the local axis of the shell. Okay, I'll just show you the local axis first. Okay, I'll just go for the 3D.
There, yeah. That will be like 1 degree. The column
So
will be out
if you can see
from
here,
the beam, at least 1 degree.
if you can see here, I'll just open one wall. Wall 1 and
He was talking
I'll just
about the
select top
Excel,
slab
like,
and bottom
won't
slab.
Look good.
I'll just
ऐसे सीधा
select
line जैसे जाएगा.
bottom
It's better
slab,
to have
select.
arcs. I'll again have a word with Sandeep on this. He told me that Vivek sir will also agree.
So now can you see here? Which one is the one direction? Which one is the one direction? Which one?
Red plus
Yes. RGB. Okay. You know RGB.
That's it.
So one direction is along the wall in X. So this is the one direction along the wall. Okay, along the wall, not X of global. It's a local axis. So along the wall, it's a one, and vertically, it is two direction. G is nothing but the two. 1, 2. This is 3.
Yeah, right.
So
Right.
along the wall, it is one direction, and vertically, it's a two direction. Understood? Now come to the plane or base. So red is this one, this direction, and G is that direction. If I want, the moment value, and from that moment value, I want to calculate this reinforcement along R. Okay, along red. So I will check M11. Okay, if I want the reinforcement in this direction, I will check M22. Understood? Understood?
yes, sir.
Yeah.
Yes, sir.
So if you're not understanding, just tell no. Okay, then I'll explain again. So now come to the walls. Okay, I'll just open one more wall which is along that direction, another direction. And just select this area. So I've selected one. I'll just select wall 2 also. Yes. So now this is wall 1 and this is wall 2 and this is the base. Okay. So if I want to calculate this reinforcement for the wall 1, so I have to check the moment 1 1, and from that moment I will calculate the AST, and I will provide the AST for this direction, correct? Because our red is along the, yeah, red is along this line, whatever I am drawing. I'll just change the line color blue, otherwise you'll confuse. So this one, and if I want to calculate the vertical reinforcement, I'll go for 2 M22. Okay, this is M22, and for this M11. For this wall, wall number 2, if I want to calculate the vertical reinforcement, I'll just go for M22, and for this reinforcement, I'll just go for the M11. Okay, and if I want to calculate this reinforcement, I'll go for M11. Because my one red direction is along this line. Okay, and if I want to calculate the reinforcement, this reinforcement, so I'll go for M22. Okay, understood? So one more thing, if so we'll get the M11 and M22, so we have to divide, we have to calculate reinforcement for M11 and M22, and we have to distribute those reinforcement in 2 layers. Okay, let's say this is my wall. We have to give 2 layers of reinforcement. This one, it will go like this because there will be footing, and this will, there will be base at the, there will be base, here it will be base of the footing, or this base. Okay, so if I am calculating this M22, and we are giving the reinforcement vertically, so that reinforcement we have to divide into 2 parts, because we need in 2 layers. And if I am giving the M11 reinforcement, this green color, so we have to divide, you divide the moment into 2 parts, or you divide the reinforcement in 2 parts. Okay, how you have to do it, just that thing I'll tell you. Okay? Understood? Because you have to provide in 2 layers. Okay, so now we'll see the value. Okay. Go to display, share, force, share and stresses, show forces and stresses on shell element. So strength combination, strength envelope, and M11. Okay, so now we'll see the values for M11. M11, which direction? This direction reinforcement.
सर
Yes.
तो स्ट्रेंथ एनवेलप में सभी टैंक फुल टैंक एम्प्टी कॉम्बिनेशन
Yes,
दोनों
all the condition. That's why its name is envelope, na? You have,
Yes,
to, you have to put all the combination. This, I think we have 2 combinations only, correct, na?
सर्विस में कौन से सर
Service means just remove 1.5.
ओके
So M11, then we'll check the value. So just move your cursor from maximum value. From here it's 51. Okay, if you come here, it's like how much? 15, 15, 16. Then it is reducing to 2, 1. Then again it is increasing. You know how the bending moment diagram is? You can see here it is plus. Okay, and here it is 1. It is reduced to.
Sir, in designing a water tank, which method we use? Limit state or working stress?
See, you actually it's a working stress. Okay, Generally use the working stress method to design the water tank. Okay.
Sir, here load combination is like 1.5. It is limit state.
See, limit state, you if you check for the crack width and all, so if it will pass, it is fine, I think.
For checking the settlement, it is only the service.
Yeah. So if you
For
want to,
designing it is like LSM limit state.
so if you want to design, see, I have given the factor of safety 1.5, okay, and all the combinations. So if you want to design for the working stress, I think give 3 value and you design for working stress and check for the crack width. You will pass it,
Means
it's fine.
we have to check the moments according to service envelope, and we have to design it according to strength envelope.
Yeah, design with strength envelope only. Check the settlements. No, check the settlements for the strength envelope, service envelope, and design with the strength envelope. See, we have how much value? 59. Okay, now it is how much it is? 16, 13 is to 1. Okay, and then this here is for 52. So what is the maximum value? 51. Here is the 51 value. If you see here, this side, it will be less only. It will be less value only. So take the maximum value. It is 50, 51, 52. Okay, 52 or 53. Just take 55. Okay. And what is the width of this wall?
230.
I think 230. Yes. 230. So what we do actually, so now first we are checking for the wall 1. So for wall 2, how much it is? $34 something. Okay. So check for the minimum also. Okay, and take the magnitude. So minimum is how much? So some, see, if you check for the maximum, it is coming in positive. You know why? And for the minimum, it is coming negative. So for the maximum, it is coming 52 or 53. Okay, and if for the minimum, how much? It is 35 or something, 35. Okay, here it is 24 only, and it is negative. Now why? It is in negative value. So negative means just, if you want the answer, just go for the local, just open the local axis. So you are checking one value. So maximum minimum means so if it is coming this side, so positive, then it shows the positive value. If it is going outside, then that is called negative value, because you can see deflection for this plane. The deflection, this deflection will, or the moment diagram will be in this direction. So it shows the positive value. If it is that side, actually how the moment diagram will be in actual. So let's say this is my wall. Okay, my one moment diagram will be like this, since it's a fixed support, and another moment diagram will be like this. Okay, so for this moment diagram, this is first and this is second. For first moment diagram, it shows the positive value because you can see the blue line. Okay, it is to inside. Okay, so that's why it shows the positive value. What is the values are coming, 50 and all those things are positive value. And for this moment diagram, it is coming negative value here. So it's a negative value. I'll just open that. Go to display. I think here only. Yes. One minute. Yes, correct. So but you have to take which value, you take the magnitude. So you have to take the moment as 52 only. Okay, take the maximum value. So how to calculate the AST? So moment, how much? We have the moment 52, and this value you keep as it is. So span per meter you design for the per meter, and wall thickness is 230 mm. Okay, so FCK is how much? We have to know how much. What is the grade of the concrete? I think 30 only. 25. Can you see my Excel sheet? 25 FY 500 only. These values are same.
If you have any doubts, you can ask or you can start working on your website.
So cover you can consider, yeah, 30 only, no problem.
Yeah. You want.
So you can see the design. How much AST? So provide 10 mm at 100 spacing. Okay. So 100 spacing, but you have to distribute this reinforcement in 2 layers. So what you will do, you will provide 10 mm at 200 center to center. Okay. What you do actually, if you want to divide this, so 52 divided by 2, 26. Now you can give, I have divided the moment value only. So now it shows how much. If I want to provide 10 mm diameter, so it shows 10 at 225. Or if you want to give the in each layer, okay, if I want to give 52, so it's 10 mm at 100. So let's say if you want to change the diameter of the bar, so it shows 8 mm diameter at 75 spacing. So you can go for this option. So 75 spacing, you just divide this in 2 parts, okay, 2 layers. So it will be 8 mm at 150 center to center. You can provide this, or you divide this moment 26.
But that might not be required. You can give only at the last floor.
So 8 at 150 center to center. Okay, you can provide. How much AST provided? 335. So according to the 52, we are providing 670 mm per meter. Okay, understood. So for the horizontal direction, this reinforcement you have to provide 8 at.
That is not a problem, but you can think about reducing area if possible. The depth here.
8 at 150 center to center in each layer. So you'll be having 2 layers here. Okay, 2 layers.
And one more.
So
thing
similarly,
is,
you check for this also, it's 52 also here. So you provide the same reinforcement, 8 at 150 center to center in all the walls. Horizontal rebars will be 8 at 150 center to center in 2 layers. Okay, each layer will be 8 at 150 center to center. Understood? So now come to the vertical reinforcement. Now we have checked M11. So now come to the base also.
See, Yeah. We need to do.
So base
If
it
you
shows
want, you can
45.
take a little bit high also, 3.5, because it's not residential or commercial space. Go for 3.5.
So how much
Yeah,
is
you can go for
approximately 46 here? It will be less only. So maximum is coming here 46. So just approximately that much area only, 150 center to center. If you put here 46, so approximately same. Okay, same, not same thing. 75 means you have to provide in two layers. So 150 is fine. So understood this direction reinforcement. We have calculated this already.
Okay. Yeah. It's fine. If you're
Now we'll
not
check for
considering
the.
that in the
I
slab,
think
then giving
we'll
it
see that
is fine.
we'll see the top reinforcement also.
So
Top
then
slab.
you can reduce slab, no? You can reduce a little bit in the slab. So there the calculation that 15 is not including the wall, right? Then it's fine.
Here my moment value is maximum is 36, 37. For maximum how
No,
much?
here in ETA is directly transferred. No, adding.
23 it is less only.
It's
Okay.
not required.
So 36.
Transfer, that's below the
So you can provide the same thing for the top slab. So now come to the M22. Next, what is M22? Yes. Yes.
You are anyway. Right.
Sorry, I got disconnected. Yes, someone is asking question. If you have doubt, you can ask.
Yeah. It
So
will
now
not
we'll see the
govern.
M22
It is
value.
just for practice. It will anyway not govern. We can just apply and try that.
So M22
If
value.
you don't apply also, no problem.
So M22 will be vertical direction. Okay. So how much it is?
Yeah,
It is showing
because
70,
now you are starting
76,
to apply.
73. I think
Just
76.
apply and-
And here it is 36 only. So I'll take the minimum also.
Mhm.
It is less only.
Yeah,
Okay.
because it is light and weight.
Now I'll see for the bottom slab. So I got 76 value. Okay. For this maximum value, I got 76 value. How much? 76. Approximately 77. So just put 77 here. Okay. Thickness is 230 only. So now you will provide, let's say 12 mm diameter bar. So 12 at 100 center to center. Okay. So in two layers.
No. It is
Just
not
provide
for the-
12 at 200 center to center.
Basically for, let's say,
12
when you
at-
idealize this, let's say you have.
I'll just write it.
Red frequency, you cannot go more than, see, I have seen people giving columns as long as 1.2 meter deep also. The same project.
So vertical bar will be.
Okay, so you can go as long as that, but what will happen is your idealization happens in only one direction,
right.
whereas in like you have three directions. I mean, the stiffness and the contribution of resistance is coming from three dimensions on the side in actual. But you are idealizing only one direction to be extremely huge than the other.
So horizontal reinforcements
Very,
are
very high than the other.
8,
Correct. 2 and 3
at
direction. So that
150
is why you are doing this experiment. So here, if you talk
Center
about
to
the
center.
homogeneity of the project, this particular stiffness
And,
is
vertical
ideal
bars are
because this particular building is
12.
governing in reflection. And you also have a
12 at
restriction features in row
100.
2. You cannot increase
Center
the
to
cost,
center.
increasing grade will not help. Because increasing grade will increase compressive strength, right? So that will
It's
again
there,
reduce
okay.
stiffness. That is not possible in a remote. Here,
So
design
now
mix
we'll
is close
see.
to impossible, right? So you can go for normal mix, nominal mix only. Till M25 only you can go. So all that is a restriction.
Now we'll
In
see
that
for the
case,
base.
just idealizing it as a sugar so that you get more resistance and the force absorption is also better.
You see for the base, okay, you just apply this value and we got 50, 58, okay, and here it is 16 only.
Yeah, fine. It happens like that. Fine. Yeah, because slab
41.
and beam are cast as monolithic.
So you will provide 50 only. How much will provide? Will provide 53. Will provide 53. I think 8. So
Yeah.
will not give 8 mm diameter for the base for this direction. So I'll just put 55. So 12 at 150 center to center in each layer. Okay. So in 2 layers. So let's say how much you can provide. Let's say I'll just provide 20, 28. Don't give neck to neck, just increase little bit. Let's say provide 30 in each layer. So it's 12 at 300 center to center. You go give 12 at 250 center to center. Okay. In 2 layers. Okay. I'll just write. So base also will provide 12 at 250 center to center in both the directions instead of 8 at 150 center to center. Okay.
So can we provide the 10 mm for this base?
I think 12 will be better. 12, start with the 12 for the base, and for the walls you give 10, 8, no problem. But for the vertical bars, you give at least 12, 10, 12. Okay, 10 also you don't give. Vertical you give 12. Okay, horizontal you give 8 or 10. Base you give 12 only.
But here there will be a problem.
So in Excel sheet,
Going for a grid here.
beta view value is there.
Except this, I would suggest you take this grid, no?
Sorry.
In Excel sheet, beta v value,
There.
In Excel
that
sheet?
you can change, that you can change.
beta v in below the moment, design moment.
So beta b is like some constant. You check in the code. Okay. Better to check in the code. They have given the constant values. Okay. I think no need to change. I think this is a concrete property only.
You just
Don't
work on the iteration
change it.
and then tell us, like, you have to work around which will suit best. Okay.
Understood. So next is, so we have checked the bottom, base. Now we'll check the top slab reinforcement. So top slab we have 22 maximum. Here 22, 23.